Thank you, Brian. So I'm honored today to introduce the opening featured speaker, Dr. Nicole LaDue, who is a discipline-based education researcher from the Department of Earth, Atmosphere, and Environment at Northern Illinois University. Dr. LaDue's research leverages methods and theories from cognitive and educational psychology to solve problems in geoscience and STEM education. Please join me in welcoming Dr. LaDue.
Thank you for having me. I will now try to share my slides. All right, is everyone seeing my slides? Great. Great, well, thank you so much for having me. It is a big honor to be here and to get to represent my small but mighty community of the geoscience education research community. I'm going to talk a bit today about a variety of projects, not getting too deeply into any one project, but focusing on how collaboration really facilitated that work moving forward. And to sort of set the stage, I thought I'd remind us of some of the definitions that were put forth in the DBER report from 2012. So it's been about a decade since the DBER report happened. And at that point, that was led by several white papers were commissioned for the different disciplines. And the charge of that group was to define what is discipline-based education research. So the definition that they came up with had 5 components: how people learn, the nature and development of expertise, because in fact we are discipline-based, so we wanted to really understand how people learn in our fields, as well as instructional approaches, and how we can translate our research into practice, as well as broadening participation in STEM. And within that report, they said that high quality DBER must have expert knowledge in our discipline, as well as an understanding of the challenges of teaching and learning, and a general understanding of the science of learning and teaching that comes into DBER from other fields like education research, psychology. And that even though we may have expertise in our discipline, we don't necessarily have to know all of the science of teaching and learning broadly, because we can collaborate in multidisciplinary teams to be more effective. So one of the big outcomes from that large report was conclusion 15 about how collaborations can result in shared methodology. So if you're doing something really innovative and exciting in PER, or you have a finding there, we can transport that into BER and see if we find the same kinds of patterns in another community. The other thing we can do is we can import and collaborate beyond our bounds to bring in the methods from cognitive psychology, ed psych, social psych, and all the fields beyond DBER. And so fast forwarding to about 2016-17, there was a meeting called TRUES, and coming out of that meeting was the proposal that we would have something called a STEM DBER Alliance. And so we might work across our boundaries to try to build momentum for STEM education. And so you would have collaborations across geosciences, physics, biology, chemistry, engineering, room. And I wanted to point out this figure because it shows that all of these fields, they are deeply embedded in our discipline, but they also cut across education research and related disciplines. I also want to point out that the GER bucket is, some people use the term geosciences to be inclusive of a lot of different types of researchers, but some of those researchers don't necessarily think of themselves as geoscientists. So I wanted to acknowledge that we have a burgeoning ACER community in atmospheric science ed. They are running sessions at the annual AMS meetings on education research. There's an astronomy ed research community that often associates with physics and publishes in physics ed journals. And then there's environmental education research. So there's 2 EERs to consider. So we have all of these small communities that sometimes get lumped into GER, but I wanted to make sure that I mentioned it, since we are tiny compared to some of the other communities. So the part of this that I really want to focus on today is on collaboration and how collaboration beyond my borders, within my institution, have really influenced everything about my work. So I'm going to talk about 4 projects. And as I said, I'm not going to get deeply into the nitty-gritty of each of the projects. The first one I'm going to get kind of into the nitty-gritty, but the other 3 I'm going to give you sort of an overview, but just really focus on how the collaboration moved the work forward. So the first project is, before I get into the first project, I wanted to give a little background and context, and I had a wonderful introduction, but how we ended up doing what we're doing has a lot to do with where we've been. And I'm at Northern Illinois University. It's an R2, so we're predominantly a teaching institution, a state institution. We do a little less research than an R1, and I'm in a newly merged department. It's a mouthful, but we merged geology and geography and atmospheric science, and now we're Earth, Atmosphere, and Environment. And part of my role, I have a dual appointment where I teach methods classes for pre-service teachers. Now, I was one of a cohort of new GER D.BER graduate students. So we're sort of the first wave of people that were trained in GER. So clearly the geo-ed community is a little bit more nascent than physics ed or bio ed or chem ed. So I was sort of that first wave about 10 years ago. And while I was at Michigan State, I was really interested in spatial thinking. So I did a lot of coursework in cognitive science, which helped me get some grounding in the sort of basic principles of that community. Now, before I even went back to graduate school in my 30s to do what I'm doing now, I was a high school teacher. And when I chose my licensure program to become a teacher, I didn't do my research, but it turned out that Cornell University was a hotbed for constructivism, conceptual change. They did a lot of the really primary research in the 80s. And so the lens that I was learning how to teach within was very, very deeply grounded in theory. And that has had an impact on my thinking about teaching and learning throughout my entire career path and today. So I felt like I needed to acknowledge that because a lot of us ending up into D.BER from a variety of pathways. Okay, so the first project I wanted to introduce to you is about the augmented reality sandbox. And this came about in part because of a collaboration with Tim Shipley, who's a cognitive psychologist at Temple. He was a vision scientist, and that's how he was classically trained. And then about 15 years ago, a little bit more, National Science Foundation was funding science of learning centers around themes. And there was one called SILC, the Spatial Intelligence Learning Center. And it was a collection of mostly learning scientists and psychology departments. And that collection of psychologists found geology particularly interesting because we have a lot of spatial problems. That is sort of the foundation of our field, this thinking in 3D and large timescales. And so Tim started to have very close collaborations with a lot of geologists and started producing what I felt was some of the most exciting research that was in GER. And so when I became a brand new faculty member, and I was the first D.BER person at NIU, we did have a couple of room researchers, but there weren't any other science ed researchers, and we don't have a footprint in STEM ed research in our College of Education. So I was a bit of an island, and I was, young enough or early enough in my career to just decide to go for it. And I met Tim at a conference and asked him for 10 minutes of his time, and I sat down with him, told him I was really interested in his research. He asked me a bunch of questions, and after that, he was willing to collaborate with me. And I really give Tim a lot of credit for helping me become the D.BER scholar that I am, because I didn't have a postdoc, and he helped me sort of transition into a bunch of projects that I started working on. So when the augmented reality sandbox came out, I knew that we needed to study it together. So I had a very motivated graduate student who had a background in computer science. It was just perfect. And if you don't know what the augmented reality sandbox is, this QR code would take you to a YouTube that shows you the dynamic sandbox that was created by UC Davis. It's a really neat toy. As you can see, it's really colorful. It's literally a sandbox. You have a projector that reads the elevation of the sand and projects topographic lines and this color ramp onto the elevation of the sand. And as you move the sand around, the lines shift and change. And so as geology faculty who were always trying to teach our students topographic maps and at times really struggling with that, we all thought this is going to be the saving grace of teaching topo maps, that this is going to solve all of our problems. So they made this open source, and people started building them. You'll see these in science centers and museums. You'll see them in geology departments all over the country. There's thousands of AR Sandbox all over the country. And so a whole bunch of us started studying it, and you can see a list of various papers that started as early as 2016 and as recently as this past spring. So people have been studying to try to figure out if this promotes learning. Have we solved the topographic map problem? And no matter what type of intervention we have created, we cannot seem to find significant gains in topo skill over and above the paper and pencil labs we were already using, which was a big disappointment to us. Now, one of the collaborative projects that I was involved with for this Sandbox study, we were doing a multi-institutional study. And working with a colleague, Catherine Raker, she was talking about when the students were engaging, the Sandbox projection that you see on the right here, projected onto the sand, was mirrored onto the computer screen that was running the Sandbox. And a student said, oh, pointing to this two-dimensional monitor, oh, this looks like the topo map we're using in lab. Which for those of us that were using the Sandbox, we thought, well, that was the whole point of the Sandbox. And we didn't realize that they were not making the connection that these lines were the same lines they were seeing on their lab. And that got me thinking that maybe this is so cool that it's distracting to the students, and we're actually kind of working against ourselves. So working with Tim, we created a study. Well, first of all of these studies were done in group settings in the classroom. So the first thing we did was we decided we're going to take this into the lab. This is what cognitive psychologists do all the time. It's not a common tradition in GER. It does happen, but it's less common than some of our classroom interventions. We recruited only students that had low self-described low map skill. They had a low familiarity self rating for topo maps. We did a one-on-one intervention, and we put them randomly distributed into a number of experimental conditions. Okay, so the Sandbox, what makes it cool is that it reads the elevation of the sand and it projects these topo lines on the three-dimensional surface. So we called that 3D feedback because the information the student is getting is about where the lines would be on their three-dimensional surface. We also called the feedback on the screen. If we didn't project it on the sand, we only put it on the screen, we called that 2D feedback. So we decided we were going to test 2D versus 3D feedback and see which one promoted more learning, because we thought, well, maybe this would be closer to the task at hand. But another perspective would be that actually we needed it on the 3D surface for them to even understand the concept. One of the challenges that comes up with collaborating is language. So, we're going along planning this whole study for months, and we met with Tim, Justin and I met with Tim a couple days before we started running participants, and realized we were using the word feedback differently. So Justin and I were thinking, we're going to have them build this structure, and then we're going to ask them how they would change it, and then we're going to leave the feedback on while they move the sand around. So they're going to see how those lines shift as they move the sand. But Tim thought we were going to ask them how they change it, turn it off, and then they would get no feedback while they were changing their sand, the structure. And so we thought, okay, we need a different condition here. We need continuous feedback or discrete. So that led us to need to have a 2x2 design. So just to make sure that everyone's on the same page, we had them build a thing to match a map. Then we either left it on, and so as they moved the sand to match the map, the lines shifted, or we turned it off and they had to rebuild it, and they didn't find out what it was going to look like till we turned it back on. So that's the continuous versus discrete. All right, so the pre and post was a topographic map assessment. Fortunately, that Silk group had created this topographic map assessment, so we were able to use a research validated instrument. And we gave them a very, very preliminary topo map training. So this connects lines of equal elevation. We got them to get comfortable thinking out loud while they were doing the task. And we gave them text descriptions of the feature and a simple topo map of the feature that we wanted them to create. So this is a hill. A hill is an area of high elevation, described by circles, connecting points of equal elevation, for example. So the students came in, they read that text, and they got the landform map prompt. They had to construct it, and during that time, they weren't getting any feedback from the projected image on the sand or on the 2D monitor. Then we turn either the sand or the monitor on. They had to then analyze, how is your map like the map that we wanted you to create, and how is it different? And then that's where the continuous or discontinuous or discrete came into play. Then they either could change it while it was on, or we turn it off. And then after that, everybody got it on, had the screens turned on, and they had to analyze their structure and identify it. And we did this 5 times with 5 different structures. So this was a 2x2 design. So they either got feedback on the monitor or on the 3D sand projected on the sand, and they either had continuous or discrete. So what happened? We see, averaged across all 4 conditions, we see significant improvement in topographic map skill. And this was the first time that we found this. Now, I want to remind you that we took away the noise of it being in a classroom. So it was a one-on-one condition intervention. We recruited only the low map skill people, and it was very deliberate training rather than having sort of a walked through activity in a group setting of a classroom. If we grouped the 2D versus the 3D, so getting the projection on the monitor versus overlaid on the sand, the 2D was almost twice as effective as the 3D. So that sort of supports our hypothesis that that when we had the task closer to the actual outcome that we wanted, the topo map, that people were more successful at doing that mapping. So why would that be the case? Because the projection on the monitor was closer to a real topographic map. The other interesting thing, if we want to start thinking about how this would come into play in practice, is that if we looked at how long people spent on essentially in their whole intervention, the discrete condition took less time, because of course they had to make their changes without seeing what the lines were doing. And so they didn't play as much. And that's really interesting, because if you're teaching, you want something that's really efficient. You want to get more bang for your buck, basically, on the intervention when you're in a busy classroom and you don't have a whole lot of time. So we think that this discrete condition and the 2D feedback was more like the outcome that we wanted, more like basically the post-test that we were testing. And not having that feedback during the model changing focuses people on the actual task we're interested in. So the suggestion we have for people who are trying to use this in the classroom is to not necessarily do a whole class intervention here, but maybe you've reserved this for the students that's really, really struggling, and you pull them aside, you bring them over to the sandbox, and you do these iterations with just that 1 or 2 students that are really struggling, to help them get the conception of what these lines represent. Now, the whole point of me telling you all about that wasn't to tell you about this great study about the AIR Sandbox necessarily, but to highlight that through that collaboration, what we realized is that we were using language differently. So feedback for Justin and I meant a different thing than it did for Tim. And that led to a really exciting part of the intervention. We also did this 2x2 experimental design, which, experimental research is not something that I had as much experience with as I had other things, and it doesn't tend to be the average normal research design in GER. So that was also really exciting to bring in those types of methods. So the next project I'm going to talk about is also a project across disciplines. So I said I worked with Tim on this project, and he was a collaborator on my first NSF grant, which was incredibly helpful. Third submission, third try is a charm. But getting to collaborate with him on that, he brought me into a science of learning network proposal that brought in geoscientists, an educational psychologist, and cognitive psychologists to look at spatial thinking in the geosciences. And during that collaboration, we had been having conversations about active learning. And a few of the meta-analyses had come out And when you read those meta-analyses, what you find is that the description of what constitutes active learning is a very big bucket of things. And that's not to say that each individual study on active learning isn't grounded in theory, but overall, there really wasn't a theory of active learning. And coming from educational psychology, Doug led an effort to do sort of this interdisciplinary crosswalk to figure out how would we define active learning and what is the theory under, supporting it. So they went to the journal Psychological Science in the Public Interest. This is a high impact factor journal. It's read widely, and you have to propose papers to that journal. And they assembled teams they recruited teams from all the different X-DBER communities. And they asked us to write white papers. So I led the geoscience team, and we wrote a white paper, and then Tim and Doug tried to kind of pull together and synthesize across all these teams a definition of active learning. And they came up with a model, which is probably not going to be much of a surprise to all of you. But it's helpful, I think, for people particularly who are coming into X-DBER to think about this. So if we think about traditional learning, the lecture, the sage on the stage type of teaching, typically it's the instructor, the professor, the teacher that has the experience with the data in the domain, and they impart that on the student. But in an active learning setting, the student is at the center of learning, and there's a variety of things we're engaging the student with. So they might engage directly with real data or real models, and they would be that their experience and their learning is mediated by the instructor, by their peers, and even by metacognition. So this zone where the student is engaging in all these different strategies is what we would consider the active learning strategy zone. So the definition, the synthesis definition that came from across all of these disciplines is something that's going to potentially sound a little familiar for some of you. So active learning is when we explicitly engage students in having agency for their learning through direct experiences with phenomena, engaging with scientific data and scientific models, and engaging in domain-specific practices. So for the geosciences, field-based learning is a big component of what we do, and that's a domain-specific practice that we highlighted in our white paper. Now, if you do approach any K-12 research, you'll see that there's some themes here. It's not surprising because it's emerging from the disciplines that are very reminiscent of the science and engineering practices in the next generation science standards. Now, because we did this white paper, and I know this was also the case in the bio community, we turned this white paper into a manuscript for our own discipline. So our white paper used an engagement lens to think about and connect all of the research on learning in the geosciences to one of 4 categories. And so our team put together somewhat of a literature review, assigning things to these categories of emotional behavior, behavioral, cognitive, and agentic engagement that comes from Sinatra et al. 2015. And what was helpful about this was thinking about these overlapping spaces when we have studies that are looking at strategy use, but also motivation. And then we also were able to identify where we really aren't doing much research or where we haven't been putting much emphasis in our community. So this was a helpful way that, yes, the combined collaboration across X-DBER definitely help move, provide a consensus definition, but also the work of building that led to a wonderful tool to move the geoscience community forward as well. So highlighting the collaboration aspect of this, working across these disciplines, it wasn't necessarily easy for Tim and Doug to navigate the different communities and our norms, but that synthesis definition is very meaningful and useful for us to go forward with. And I think that this exercise did also infuse our disciplines with some new knowledge that we didn't have before. Now, these first 2 projects are talking about how we can kind of grow or what benefits we get from collaborating outside of our bounds. And the next 2 projects I'm going to talk about are really about me reaching in to my institution. So as I said before, I was the first X-DBER identifying person at NIU. And I felt a little lonely over here, which is partly why I collaborated outside of my institution. But in recent years, we've had some people that joined NIU that I've started working with. So a few years ago, so I started in 2013. Heather Bergen-Roller from biology started, I think, 16 or 17. And more recently, Rachel Ruppnow, and we have another method room person who joined a couple of years ago, and a postdoc in chem-ed research who joined us for a few years during the pandemic, unfortunately. And we started meeting informally. So I was so excited to have people to play with that we started meeting you know, every month to read papers and to share our work and get feedback from each other. And then when the pandemic hit, we had, you know, everybody on this team except for myself was pre-tenure, and we were all a bit worried about our productivity and saw an opportunity. So the Journal of Chem Education just had released a special issue call on teaching during COVID. So we decided to collaborate on a qualitative study to understand how the chemistry department had been responding to this. Now, just for a little context, at NIU, we have DBER/room people in all of the departments except for chemistry. The chemistry department, as you are probably well aware from your institutions, services all of the STEM or the science departments. So we rely heavily on the chemistry intro courses in biology, physics, engineering, geology, and yet they don't have a DBER person yet. I'm working on that. So we had this, Nicole James came as a postdoc. She was a DEI postdoc from an internal call, and she was transitioning from physical chemistry into CER and was trying to work on transforming one of the high equity gap intro courses. So it was a nice opportunity for us to study the chemistry faculty and sort of the state of affairs in the chemistry department without somebody who's sort of vulnerable as a pre-tenure scholar in that department. And because we had this wonderful postdoc who was able to do some literature review, and Rachel had experience with some of the teaching practices theoretical frameworks, they found the teacher-centered systemic reform model. And we designed a study where we interviewed 3 associate professors and 3 full professors about their teaching practices during that sudden shift to remote instruction. So this happened in May, June of the pandemic. So it was right after the faculty had just made this rapid switch. Now, the outcomes of this study are not going to be particularly earth-shattering for any of you. But I think what was really meaningful was that it helped us get a deep understanding about what was going on in our chemistry department in a way that you know, was a little less direct than if we would just walked up to chemistry faculty and said, you know, tell me what you think. So not surprisingly, our faculty were very comfortable, and they remained in their didactic teaching centered practice. They used class sides, online homework systems related to the textbooks, but they were more likely to use asynchronous, recording their lectures for asynchronous viewing, which really helped our students handle the transition. They were more likely to use animations. They were more likely to use formative assessments like polling. And they talked about how empathetic they were towards the students' struggles. So I think for some faculty, they were learning more about what our students were already dealing with. So at NIU, the majority of our students are first gen or have high financial need. And so many of them are working half to full time while doing their STEM degrees. And the students, particularly during the COVID, were working in either they were either in the service industry or they were frontline workers in the health industry. And so the faculty became very aware through this time how much stress that those students were under while they were trying to complete their chemistry coursework. One of the big concerns that the chemistry faculty talked about were the fact that they lost that all the cues that they get from working with students face to face. And that they were concerned about rampant cheating. So a lot of the types of assessment that they were using are the types that lend themselves to cheating in an online environment. I'm sure many of you have heard similar themes emerge, but this did force them and push them to start thinking about learning differently. And truly, I guess selfishly, one of the most exciting outcomes from this project was the fact that we got to know each other much better. So we had met for these, journal club meetings, but we were now learning methods. So Nicole, Heather, and I really had very limited qualitative research experience, and we're able to learn from Rachel some of the methods and practices that she uses regularly in her research. And since then, Nicole James, our chem ed researcher, has gone on to work at Reed College and furthered her work as a CER. But now Rachel and Heather collaborate regularly on a new project, and are also, Rachel has been serving on some of Heather's committees for her graduate students. So it really moved forward the sense of community that we have for DBER at NIU, which is really exciting to me. So the outcome of this collaboration was really building relationships within the institution. And I probably didn't add this, but also taking the temperature of what is happening with practice within our science departments. Okay, so the last project I'm going to talk about, I realize I'm talking really fast, but hopefully I'm keeping you awake over there, is a project that came out of an NSF STEM project. So it's a track 2. The institution, a different group of people had a track 1 many years previous. And at the time when we went for a track 2, there was a required research component, which is now just a suggestion, and you don't have to do that till you do a track 3. So while we were building this project, to be totally transparent, I knew just enough to be a little bit dangerous. So I knew from my previous work that social support was really the way that we help build belonging and persistence for low-income, underrepresented students in STEM. And I knew that that's what we needed, but I didn't necessarily know how to make that happen, right? Other than getting everyone in a room to talk to each other, I didn't have a technique for how to make that happen. Fortunately, there was someone over in the College of Education who studies this. So Daryl Dugas, I met because he teaches one of the courses that our pre-service teachers take. So I had met him in passing, and we had never really worked closely together. I just knew who he was. And in talking with him about this grant, I learned that his whole entire research program is about generating social support and running groups where he's trying to get the students to build relationships with one another. So he had a lot of expertise to bring to this project. And we had complementary interests in the project. I was interested in the research part of it, and he was interested in the programmatic part of it. So the other challenge that came up with this, and this is a challenge that happens for many of us, most of the people who do GER and have research programs are at R1s, and they're in really nice towns with a lot of opportunity. And NIU is an R2. It's a smaller school, and we're out here in the corn and soy fields. And it's a little bit harder for me to compete with, really groovy coffee shops and vegan restaurants out here in the cornfields. The other thing is that we don't have the same parity in terms of what we pay graduate students. So I had a graduate student for the first year of this project, and there's a graduate student on the project now, but there was a gap in between there where I didn't have a student to work on this research with me. And in talking to Daryl, as well as our evaluator who's in our educational research program in the College of Ed, I learned that those students are required, their graduate students are required to do an internship. So they are trained in qualitative methods and quantitative methods, and they need to spend a semester doing a project. And I could be their internship coordinator. So I was able to leverage these amazing internal resources of these students who had great training to come and work on these projects. And so they got the experience of practicing their skills and practicing them in contexts that are different from the ones that they're doing for their masters and their dissertations, as well as we just got these human resources to do the work. So that was an incredible boon for this project. So a little bit of context, our Belong in STEM program, the STEM program, provides academic support check-ins with faculty every semester, professional development events to help students think about their career path, as well as weekly social support. So our intervention that we were most interested in studying is how this weekly peer group affected students. And they all have high financial need and receive a scholarship, which frankly is way too low for how much need our students have. So to give you a bit of context as to kind of what we all contributed to this collaboration. So for the program side of things, I helped with logistics and the grant management. And my colleague in Ed Psych, his expertise was in mentoring the students to be peer mentors. So we have a number of graduate students. At any given time, we've had 2 peer mentors, but sometimes we've had only 1 when we were first starting out. And then the graduate students run those peer groups. So right now, Liz is a traditional biology PhD student, and Madison is a GER graduate student working with me. And they are both mentoring, facilitating these weekly peer groups. Now, on the research side of things, I was the one mentoring the graduate students in writing manuscripts and designing the research. Daryl has experience in qualitative research. So when we didn't have a graduate student to run the interviews, he would lend his hand to the interviews and help with inter-rater. And then the graduate students are also doing interviews, developing code books, writing manuscripts. And so here we have Erica and Madison, who were my graduate students in GER, but we also have Em and Sadia, and then there's another graduate student, Stephanie, who's not pictured. And they've all been involved in writing these manuscripts, which I'm hoping will be published very soon. And so just a plug for a poster that will be appearing later today, presenting some results from our first year of interviews. The peer groups were helpful for our students because they helped provide a structured space for them to share struggles, their academic struggles. It reduced their isolation and pushed them outside of their comfort zone. Interestingly, their comfort zone was not making friends. It was just showing up, doing their coursework and leaving. They didn't want to make friends. They wanted to just get their work done because they're busy. But this structured environment of the peer group forced them to take the time to de-stress. It helped them build relationships and can connect over identities that they didn't realize they shared. So we have some really interesting quotes about that. So the benefit that we got from this collaboration was, Daryl really likes to teach. He really wants to build these peer groups and facilitate social support. He doesn't really want to publish as much as he wants to build the thing and run the program. And I'm really excited about publishing and designing the research. So we really, we jokingly say that we feel like we're taking advantage of each other because I get to do the thing I like to do. And he says he feels like he's taking advantage of me because he gets to do the thing he likes to do. And so we were able to really, find a nice partnership there. We're also leveraging resources. So sometimes I don't get the graduate student I hope to get. And here I have an opportunity to use these interns from the College of Ed, and they've been a delight to work with. Okay, I would be remiss not to use my lovely platform to get on my soapbox about a few things. So I'm going to just wrap up really quickly with that, and then we could take some questions. So the first thing I'm going to say is K-12 teachers are thoughtful graduate students. So this is not tooting my horn, but I have a PhD student now who has a 25-year career in as a K-12 teacher. And I just want to point out to those of you who are not as closely connected to the K-12 environment that most of us have spent a lot of time thinking about learning on a very deep level, even within our discipline, in a way that a lot of higher ed researchers haven't necessarily been thinking. So I encourage you to, when you see a K-12 teacher apply for your graduate program, give them a second look. I think that when we collaborate beyond our traditional borders, we enrich our work. And I encourage you to, if you're at a PUI or an R2 like I am, to just, go for broke, cold call your research heroes, try to find a collaborator at an R1 because it helps you be more productive. And they have structures that you might not have access to that really can make your research grow. One of the things that has really made NIU an exciting place to be is working with my colleagues. And that all started from informal meetings. And now it has grown to be quite a nice collaborative environment. So I encourage you to find those people inside your institution, take the time, which is hard when you're pre-tenure or when you're busy, to have those coffee, get together for coffee with people and get to know what they're interested in. And I don't get to do a whole lot of spatial thinking research these days, but fortunately, a couple of my colleagues have been inviting me to be external members of grad committees to other institutions. And that has really helped me kind of use my spatial thinking, cognitive science background tools. And it I think it has helped them infuse their grad committees with another perspective. So I encourage you to do that if you are running or advising PhD students grad committees. And with that, I think I'll take some questions, and thank you so much for inviting me and having me here today.
Awesome. We have a couple questions in the chat. Someone would like a reference to the TopoMap study, if you don't mind sharing that.
The AR Sandbox study or the previous?
I think it's the AR Sandbox study.
Yeah, so this is where I sheepishly tell you that my graduate student, Justin, went right into teaching in the classroom. And so it's his thesis right now. So if you Google more and AR Sandbox, you will find his thesis. I am going to publish this paper. I swear it's going to happen. One of the things that I needed to do before we published it is you'll notice that there's 4 conditions, but none of them is a control condition, right? So we didn't do a pre-post with a different group of people. What we actually did, but they started higher than any of our other groups. So we did get a control group of data collected, and I'm going to do the statistics again with our control group. So it's coming soon.
And then let's see, another question from the other Sandbox studies. Had there been any indication that there might be benefits for students with low map skills in the classroom / group context?
So the benefits were the students talked about being highly engaged. They talked about being really interested in what they were doing. They found it, you know, they mostly it was a kind of affective response that they felt really excited about working with the Sandbox. So although we didn't see the kind of learning gains on the topo map, it does lead to higher interest, which is certainly important, right? I mean, because we want the students to keep coming back. We want to increase their bandwidth for doing the hard things we ask them to do. So there were benefits to doing the interventions. They just weren't the benefits that we maybe sought out to create.
Another question for the AR study or the Sandbox study, did the students who received only 2D feedback not see the topographic lines projected on the Sandbox? And would that take out the AR component from the intervention?
Right. So is it still AR? And that's sort of a tricky, so their experience with it probably isn't augmented. The tool itself is augmented because we can actually, the map that it's being created is generated from the surface in real time. So so there is some sort of augmented aspect to it, but their experience is not as augmented. That's a non-answer, but we certainly use the augmented reality tool in terms of generating that map. And when they were in the continuous condition, they could see how these lines changed as they moved their sand. But you're right, it's not really exploiting all of the augmented reality dimensions, which is kind of interesting.
Awesome. Another question. So we often associate direct instruction with the traditional way we teach, yet direct instruction is about activating students. Therefore, it seems to me that traditional ed to active ed are not opposites. Might need some clarification here.
Can you read that again? Because I think I started getting it at the end, but then I lost it. Can you read that again?
Yeah, so we often associate direct instruction with the traditional way we teach, yet direct instruction is about activating students. So it seems that traditional education to active education are not opposites. Marta, do you want to?
Yeah, if it's still unclear, I'd be very happy to butt in. So I'm an educationalist by training, and I've worked in X-DBER for about 20 years now. And I often come across people saying that traditional education is bad and active learning is great. But having come from a teacher training background, for me, the traditional way of teaching we associate with direct instruction, and the direct instruction model is very clear. It's about activating prior knowledge. It's about introducing new knowledge that you connect with where the students are. It's about hands-on practice. So of course the teacher is like the expert, but it is really about truly engaging with where the learners are that makes it the most effective way of teaching. And then ever since I moved into DBER research, I hear that traditional education is bad. It should all be about activating students. And I couldn't agree more. That is really important. What I have always struggled with is this idea that apparently the traditional models do not activate students and are therefore bad. And therefore we need to move to all of this active learning. But to me, this is just a continuing of the same thing. So I was just really interested in hearing your thoughts about this.
Exactly. So I agree with you wholly. I think that the reason that this has emerged is that active learning emerged from undergraduate education, which historically has been, large lecture halls where there's a person in the front of the lecture hall, and we're assuming, because the students have chosen to be there, that they are engaging and they are actively learning because they are engaged as they are listening to a lecture, or the lecturer is providing examples or models or right activities or examples for them to work while they're in the class. But I think that in K-12, we tend to be in smaller classes. And of course, the tradition is you are engaging students and you're the coach, you're facilitating their active engagement in the learning. I think that that's the distinction. I think that's partly why Doug Lombardi was interested in writing this paper, because I think the K-12 tradition was necessarily active. It was engaged learning, but that the majority of college faculty historically have no training in teaching or learning, right? They have a Ph.D. in a discipline, and then they're put in front of students. and now we are making inroads in that. We are providing some training for postdocs or for our graduate students to get experience training. TA training is becoming a bigger area of research in DBER too. So we're doing a better job of training faculty to think about learners in a more robust way than just in terms of our own lens of, well, when I was an undergrad or when I was a PhD student, I learned this way, so I'm going to use these techniques.
So would it be extremely bold if I say that what we associate in higher education with the traditional way of teaching is just really bad teaching?
I didn't say that.
Well, I just did. But to me, because what you're describing is a lecturer who has no clue on how to engage with students, while even in a classroom with 600 students, you can do really good direct instruction that's activating and engaging. So I think that's where my confusion comes from, that we equate something that is just, really poorly designed and executed with something that it's not. So maybe that's where I'm coming from. So thank you for your reflections.
And I would say that was an argument and something that the teams debated with Doug. We kind of kept going back, and there were more versions of it than I think he was hoping there would be as we were refining the final paper, because a lot of people were arguing the same thing, that you can do really good lecturing or large group instruction that isn't disengaged learning, non-learning. And really, what is the nature of learning? You have to be engaged to be learning. And if they're not learning, then it's, what are you doing as the instructor? But I will also say that, sure, there's bad instruction. I don't know that I would fault the person doing the instruction, because they really don't get any training to do it. So they don't.
True that. I mean, I'm the last person to say that. It's just that I'm always really surprised that we seem to have this idea active learning is good and everything else is bad. And I find that unhelpful.
Agreed. Yeah. Well, and I find unhelpful the bucket that it's all this one thing, which we're really, what I like is all these different numbers and these arrows in this diagram, which is, they're all different types of engagement.
So I think we've gone over a couple minutes, but we want to thank you very much for your time. You do have a poster during session 2, so if people have additional questions, feel free to touch base with Dr. LaDue over there. And thank you again
Thank
your
you for having me.
presentation. And we have a break, everyone, until 11:15, where we come back for 2 different poster sessions.
Great, thank you. I'm reading the chat. Oh yeah, the